5.2 natural logarithm. So what is the logarithm? If someone asks you what is a logarithm, logarithm is inverse of an exponential function. In 5.1, we did graph e power x or 2 powers or any number of powers. It's like that. If you want to find the inverse of that, what you do, you just need to find the reflection of that respect to y is equal to x. If I do that, that would be my graph. So you just reflect that respect to the y equal x. Just remind you that one is y is equal, any exponential function is incorrect. So this one is e to the power of x. Then the inverse of that, what do we do for the inverse? You just switch x and y. So x is equal to e to the power of y. So after we find the equation of the inverse, you know that there is no way I can rearrange it for y unless we invent something. We invent the log. That's why we invent the log. The log, so the base here is e, so the base of the log is e. So at the other side of equality, you put y, the exponent, and here is x in front of y. So e to the power of y is x. This is how you convert a log into that. Since log e, maybe it is really long to write it down. Instead of the log e, we can shorten that, and we write ln. So it means ln is log, and the base is e. All right, so just about the properties of that, knowing that the e power x has a horizontal asymptote, but the logarithm function, it has a vertical asymptote here. And as you see, the domain for the exponential is xer, x could be any number, and y gonna be greater than 0. But for that one, the x for the logarithm, the x is greater than 0, as you see here, and the y could be positive and negative. The y is everything, yer. So you have a y-intercept for e power x at 1. For this one, you don't have any y-intercept. It's not intercepting the y-axis. And there is no x-intercept for e power x, but there is an intercept, x-intercept, or e for the logarithm. We did talk about the vertical and horizontal asymptote. There is no maximum, so this is increasing. Both of them is increasing function. There is no inflection point, no maximum and minimum for any of these two graphs. Okay, about the log laws. Ln of e power x is x. How do we prove that? Knowing ln of e power x, we know the ln is log when the base is e, right? According to the log law, I can bring the power in front of the log. So I can write it as x log e. I hope you remember that. What is a log e? Log log a, log of any number that has the same base is going to be 1. A to the power of 1 is a, right? So log e is 1, so the answer here is going to be x. Remembering the ln of e power x is x, we proved that, right? Now e to the power of the ln x is x. Now we want to prove this. Let's say e to the power of the ln x equal to y. I don't know what is the y, right? I want to just prove that this y is x or not. I put ln in front of both of these two sides. According to the log law, the power can get in front. So it's going to be ln of x, ln of e. equal to ln of y. So ln of e is like log e, so which is 1. So I proved that the ln of x equal to ln of y. Means x and y should be the same. If you just cancel the ln, x should be equal to y. At the beginning I said e to the power of ln x is y. So I proved that the y is x. So it's proved ln e power ln x is x. I can say that e and ln cancel, so it's just x. Now, here ln e is 1 according to that e to the power of the ln is the same as the power here. It's just x plus 3 there. E and ln cancel, it's just 4x. The power in front, so it's just 7x here, according to this one. This you can simplify it 28x power 2. Now let's say we want to do solve for x. You have an equation like 7,300 is equal to 20 e power x divided by 2. You want to solve for x. So first step, you have to divide both sides by 20. So this 20 and this 20 cancel. 10,300 divided by 20 is 365 equal to e to the power of x divided by 2. Then we bring the ln in front of both of these two sides, right? Ln here and ln here. So power in front here is x divided by 2 ln e equal to ln 365. Ln e is 1, so 2 to the other side. So x is equal to 2 multiplied by ln 365. If you put that in a calculator, you'll get 11.8. So here is another example. According to the equation, n0 e power ln 2t divided by 5,100, where nt is the ratio of the carbon 12, the carbon 14 to carbon 12. At a time organism died, n0 is the ratio of the carbon 14 to 12 in the atmosphere, and the t is the age of the fossil. So n0 is initial ratio, and n is the ratio at time t. Calculate the approximate age of the fossil sample found. The ratio of the carbon 14 to carbon 12 is 10% of the today level. So 10% of the today level means it is 10 if initially we had 100. That means the n is 10 if initially we had 100. That's what 10% means. Negative ln 2 multiplied by t divided by that number. So first things we do, like the previous example, we have to divide both sides by 100 to get rid of this 100 here. Oh, sorry. Divided by 100, this is 0.1. So 0.1 now equal to e to the power of negative ln 2t Okay, I'm gonna put ln in front of both sides. So here's power in front. So ln of 0.1 equal to, I can bring the power in front, it's negative ln 2 t divided by 5700 ln e. Ln e is 1, so So I just rearrange for t. So ln 0.1 5700 go to numerator, and negative ln 2 go to denominator. So you put that in your calculator. Let's give you 17,938 years. For the worksheet here, you can do question number 1, question number 6, 7, and question number 9.